This video is sponsored by Mel Science. More on them later. Hello and welcome to this episode of Night Sky News for September 2022 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and we chat about what's been happening in space news in the past few weeks. There's chapter titles down here if you want to skip ahead to any specific news story, and any scientific journal articles I mentioned will all be linked in the video description down below. So without any further ado, let's kick things off and start by looking up. Let's start with a reminder first of why it's important to keep looking up, because you might spot something like this, a fireball meteor that was seen by about 800 people or so across Ireland and Scotland at around 10 p.m. on Wednesday the 14th of September. Now at first when this was spotted, people didn't know whether this was actually a meteor falling to Earth, like a lump of space rock burning up in the Earth's atmosphere, or whether it was a bit of space junk falling back to Earth, so perhaps, one of the Starlink satellites that had been deorbited. But from the trajectories captured in all of these videos from people's smartphones and doorbell cameras, the UK Meteor Network worked out it was indeed a meteor, a lump of rock, and anything that didn't burn up in the atmosphere would have ended up in the Atlantic Ocean around about 50 kilometers off the coast of Islay. So no chance of finding little lumps of meteorite on the ground, unfortunately. But if you want to see something similar to that, although fireballs like that are very, very rare, we do have 2 meteor showers coming up in October. The first one you'll hear about is the Draconids meteor shower, which is peaking around about the 7th of October. Unfortunately, that is when the moon is almost full, so it's going to be very bright, and it'll probably wash out all but the brightest meteors. You might spot 2 to 3 an hour in really dark skies if you're lucky. So it's not worth a special trip out, especially if you live in the middle of a city or something. But if you're out stargazing anyway, anywhere from sort of the 6th to the 10th, and you spot a meteor, then it's probably from the Draconids meteor shower. The better option is the Orionids meteor shower, which peaks on the night of October 21st, the morning of the 22nd. The moon is just going to be a little thin crescent then, my favourite phase that I call the toenail moon. And so that'll give you a much darker sky to enjoy, and look out for around about 20 meteors an hour in those darkest skies, around about 3 a minute. Now they're all going to appear to be streaking away from the constellation of Orion, which at this time of year rises in the east for everyone sort of just before midnight. So wherever you are in the world, the best chance you have of spotting these is just to go outside, lie down and look directly up above your head, and spend maybe half an hour or so to an hour just lying there, maybe with a group of friends, trying to spot as many meteors, shooting stars as you can. And fun fact, the Orionids are actually caused by leftover debris and rubble from Halley's Comet. Now, it's not just meteor showers that are set to wow us in the next couple of weeks. We've still got a fair few planets in the sky. The easiest to spot is probably going to be Saturn and Jupiter, because they're around in the early evening sky, but they'll also be joined by Mars around about midnight time. This is something you can spot even if you're in a city. So I was in New York City right at the beginning of September, around about the High Line area. I still managed to pick out Jupiter in amongst the skyscrapers despite all of the bright lights of the city. It is one of the brightest things in the night sky after the moon, so it should make it fairly easy to spot, especially on Monday the 26th of September, when it'll reach what's known as opposition, when the Sun, Earth and Jupiter will all align. It means that Jupiter's the closest that it gets to Earth, and it's perfectly lit by the Sun from the front, and it's the brightest it ever gets on the sky. I mean, don't worry if it's cloudy on the 26th, because it's going to be fairly bright in the weeks surrounding that anyway. So, whenever you do get a clear sky, look up and see if you can see it. While you're there, look for Saturn to the west of Jupiter. It'll have this slightly yellowish colour, and then look for Mars towards the east of Jupiter, which will be that very distinctive red colour. To make them even easier to spot, all 3 will make a nice line in the sky which marks the flat plane of the solar system known as the ecliptic, which all the planets, sun and moon take through the sky. Now speaking of the sun and moon, there's actually going to be a partial solar eclipse on Tuesday the 25th of October that's going to be visible from Europe, Northeast Africa and Central Asia. So this is when the moon will pass between the sun and the Earth when it's in its new moon phase, but just partially block out the sun. It doesn't block it out fully because the moon's orbit is actually tilted about 5 degrees compared to Earth's orbit around the sun, so the alignment will be off. This is why we don't get a total solar eclipse every single month where the moon completely blocks out the sun, because, you know, sometimes it passes just above the sun and sometimes it passes just below the sun. So on the 25th of October, it's going to look like the moon has taken just that little bit of a bite out of the sun. About 15% or so of the sun will be covered here in the UK, but the further east you are, that will increase up to 80%. I'll pop a link in the description below where you can put in your location and find out exactly how much of the sun will be covered and at what time locally. Remember, do not look at the sun. You will damage your eyes. It is too bright. Even with just 15% or 80% of the sun covered, it will still look like it's this round blob in the sky because of how much light is coming from it. If you want to actually see the eclipse, the best thing to do is to try holding a colander up over your shoulder with your back to the sun and looking at the image of the eclipse projected through the holes of the colander onto the ground. To be honest, mucking around with colanders is half of the fun of viewing a partial solar eclipse anyway. Alright, I think that's enough of looking up at the night or the daytime sky for now. Let's come back down to Earth and chat about what's been happening in space news in the past month. Before we get to what has happened, here's a heads up for what's coming up soon. There's going to be another attempted launch of Artemis 1, the uncrewed test launch of the mission to eventually send humans back to the moon on Tuesday the 27th of September at 11:37 Eastern US time. That was after all the previous launch attempts that we saw this month got scrubbed or postponed due to the fuel leaks in the engine of SLS, the rocket that will launch Artemis into space. Remember, as I said last month, I'm an astrophysicist. I study stuff with telescopes in space. The engineering of rockets like this is not my area of expertise. So if you want to know more about this, I'd suggest following either Camille on Instagram at The Galactic Gal or Joan Marie on Instagram at Your Female Engineer, who both work on the engineering side of the Artemis mission. As usual, all of those launch attempts are going to be streamed live on NASA's YouTube channel, which I'll link in the description below if you want to watch that live, along with the DART mission's impact with the asteroid Dimorphos on Monday the 26th of September. This is NASA's mission to test whether by crashing a spacecraft into an asteroid, we can transfer enough energy to deflect it, so that if there was ever an asteroid that was a danger to Earth, we could stop any potential collision from happening. I made a video last week all about the DART mission and the 3 things you need to know about it before the impact, including how we'll know if it worked or not. If you want to check that out, I'll link it down below. Now, before we get to our usual James Webb Space Telescope update that we do in this segment of Night Sky News, some sad news first about the passing of the astrophysicist Frank Drake at the age of 92 from natural causes. Frank Drake is most famous for the Drake equation, which is often dubbed the second most famous equation in all of science after E = mc squared. Admittedly, the equation is a little bit longer than E mc squared, but it attempts to estimate the number of planets in the Milky Way with intelligent life on that we could potentially communicate with. I talk about this equation in more detail in my video on whether I think aliens exist, which again, I'll link below if you want to know more about the legacy of Frank Drake. Alright, on to updates from the James Webb Space Telescope. And I just want to start by reiterating what I said in last month's Night Sky News video, that no, the James Webb Space Telescope has not disproved the Big Bang Theory or shown that it didn't happen. This idea still seems to be running rampant around the conspiracy theory segments of the internet, fueled by videos like this month, which somehow has 3 million views and only 14 comments. It's as if they're deliberately deleting comments that are telling them that their video is wrong. If you see any other videos or posts on your travels around the internet that are parroting this false information, at least try and comment on them to point out to others seeing it that what they're saying is not right, so that we can try and just, combat this sort of misinformation clickbait that's going around. with everything to do with the James Webb Space Telescope. In my previous Night Sky News video, I did actually go through what the James Webb Space Telescope has shown in terms of we're seeing smaller galaxies at greater distances and we're seeing more spiral galaxies at greater distances. Again, I'll link that video below if you want to check it out with all the details. Alright, on to what JWST actually has shown us this month. So we had the release of this paper revealing that Webb has actually imaged the most distant star we know of, called Earendel. Now, if you remember, I covered this on my channel before. This was spotted in images from the Hubble Space Telescope and was announced back in April 2022. Now, in the background of galaxy cluster images, we usually see background galaxies that have had their light magnified and bent by the very strong gravity of the cluster. Kind of like the light from a candle when it's put behind a stemmed wine glass. Now, usually the only things large enough and bright enough to be magnified in that way are entire galaxies of, billions or trillions of stars in the early universe. But the thing spotted in Hubble Space Telescope images didn't look like it came from a galaxy at all. All the models we had of that image from the Hubble Space Telescope suggested that the thing that was being lensed and brightened and magnified, that object, was actually only 2 light years across, suggesting either it could be a very compact star cluster, smaller than we'd ever seen before, or maybe like a binary pair of stars, or even just a single star in the universe 12.9 billion light years away, that just so happened to be perfectly aligned so that we could see it thanks to this magnification effect caused by gravity. But that was the conclusion from Hubble Space Telescope data. What about now that we've got imaging from the NIRCam detector on board JWST? Well, Earendel has remained a single point in the JWST images, and with this increased resolution that JWST has given us, Welsh and collaborators have now been able to say that this object is less than 0.065 light years across. Less than 4,000 times the Sun-Earth distance. Now that's small enough to rule out a very dense cluster of hundreds of stars, but it's still not small enough to rule out the idea of a pair of stars over just a single star. But what the data has allowed us to confirm is that if it's a single star, it's around about 13,000 to 16,000 Kelvin in temperature, meaning that it's a B-type giant star, somewhere around 5 times the mass of the Sun. And once again, we've estimated the distance as 12.9 billion light years away. But that is still just an estimate based on the imaging. What we need to confirm that Earendel is actually at that distance and perhaps, instead not just a Milky Way star that's sort of photobombing in the foreground, is a spectrum of the light, where you take the light, split it through a prism, and get a trace of how much of each wavelength of light do you receive. Different types of stars have different shapes to their traces of light, so we should be able to tell whether we're seeing the light from just one star or from 2 stars added together, with 2 of their traces added together. But also we'll be able to tell if that trace of light has been redshifted to longer wavelengths than we're used to seeing for stars in the Milky Way. Redshifted by the expansion of the universe. So if you know how much it's been redshifted by, you know for how long that light has been traveling, and then we know the speed of light, so we can work out what distance Earendel is at. These observations are planned with JWST's near-spec detector in December 2022. And hopefully we won't have to wait too long until that analysis is published, maybe a few months later, and we'll finally know what is Earendel and how far away is it. So make sure you subscribe so you don't miss any updates on that on this channel. JWST also showed off what it can do with its coronagraph this month, which is thankfully nothing to do with COVID. It's a mask that you can put over a very bright star, try and detect a very faint planet that's orbiting it. Taking a direct image of a planet in orbit around a star, so we definitely know it's there, rather than inferring the planet is there because every time it passes in front of its star, it causes that star to dip in brightness. So this was work done by Carter and collaborators with early release science data that all got made public when those first 5 images were released back in July. And this was done for the planet HIP 65426b with both NIRCam and MIRI data. So in each of these images, the little white star symbol marks the location of the actual star HIP 65426, and therefore the location of the mask blocking that light, right? But there's always some that still bleeds through. And then the bright dot in each of these 4 panels is the planet that's been detected at these different wavelengths of light, from shorter wavelengths that have been coloured blue in these images to longer wavelengths that have been coloured red. The other blobs of light, which are like especially obvious, right, in the NIRCam images, are a result of how light behaves and diffracts through the telescope. So similar to how, you can get 2 bands of rainbows appearing in the sky. Here you're seeing the light from the planet a few times. Once where the planet actually is and where it's brightest, and another couple of times where the light has been diffracted to as it moves through the optics of the telescope. You can see that here because all the other brighter sources of light, like the bleed of the starlight around the mask or the background noise, have all been removed to reveal only the very faint light of the planet. And so leave behind this pattern, which is caused by the physics of how light behaves, which is usually too faint to see for brighter objects. For these images, Carter and collaborators calculated that this planet is 87 times further from its star than the Earth is from the sun. And then from how bright it is, i.e. how much light it's reflecting, because the bigger the planet, the bigger the surface area, and therefore the more light it will reflect back, they worked out that this planet is about 7 times the mass of Jupiter. Not only that, but with these images, which are the first of their kind taken by JWST, the team could then put limits on what would actually be possible to detect around stars of this brightness, roughly at this distance for around 385 light years, and found that for something that's around about Saturn's mass, you could probably spot it when it's 10 times the distance of the Earth and the Sun away from its star, and something around about like Uranus's or Neptune's mass, you could detect those much further out, beyond about 100 times the Earth-Sun distance. But for stars much closer to us, with the improved resolution you have at that point, you can detect planets much closer in. And the team actually estimated that you should be able to directly image planets that are 5 times the mass of the Earth, anywhere from about half to 2.5 times the distance of Earth to the Sun. So I'm really excited to see what JWST does in this observing mode and what it can find. Maybe even a super Earth planet that's orbiting a sun-like star that might be actually quite close to us, at least astronomically speaking. You might also have seen this spectacular image of the inner regions of the Orion Nebula just hanging around the internet last week. This again comes from an early release science project called Radiative Feedback from Massive Stars as Traced by Multiband Imaging and Spectroscopic Mosaics, also known as PDRs for all, PDR standing for Photo Dissociation Region, which essentially means that UV photons from newly formed stars are feeding back on the gas in nebula. So there is a link between those two names, I promise. And the team behind this project, led by Dr. Olivier Bern at the University of Toulouse, have now processed all of these early release science images. So they've put out a press release and made those images freely available to the public and the wider astronomical community, if they want to use them to do science. But there's no journal article yet, either in peer review or already published, that describes what processes, what steps did they take to get from the raw images to that beautifully coloured image that they released. Which is why you won't have seen this yet on, any of the NASA official sites, like on Twitter or on their blog. NASA actually put out an official statement explaining why that was, if you want to check that out, and it's all to do with the scientific process and peer review. So for now, I think this image is just really nice to drool at, almost like, the big 5 were that were first released, but there's been no scientific analysis to report just yet. When there is, I'll definitely be covering it on this channel, so make sure you subscribe so you don't miss those updates. But for now, I think we can all just sit in awe over the improvement in resolution compared to, for example, the Hubble Space Telescope and also Spitzer Space Telescope, which was taken actually at similar wavelengths as well, so are more directly comparable. It really is just unreal. I mean, it's almost an overwhelming improvement in resolution. And I've said it before on this channel, I'm going to say it again, but good science takes time. You know, me and my colleagues are still learning the nuances of this data. We're still developing tools right now to actually help us to analyze and process this data as well. I talked about this with Dr. Libby Jones for the chat I had about what it was like to control the James Webb Space Telescope during that commissioning period and all the work she's currently doing on the images she has as well. Check that video out if you didn't see it, because it was one of the best chats I've had in a really long time. But yeah, good science takes time. So we just have to be that little bit patient. And finally, something not James Webb Space Telescope related, but a paper that caught my eye when it was posted this month from El Baldry and collaborators on the discovery of a black hole orbiting a sun-like star just 1,500 light years away, which makes it a new candidate for the closest black hole to Earth, which is definitely exciting. Or at least, you know, if the hypothetical planet 9 in the solar system doesn't turn out to be a black hole, I'd be very disappointed if it didn't. But if you wonder what I'm talking about, I've got an entire chapter in my new book, A Brief History of Black Holes, on this. It's linked in the video description down below. If you want to grab yourself a copy, I know, I'm shameless. What are you going to do? So El Baldry and collaborators found this star in Gaia data, the European Space Agency mission to catalogue the brightness, positions, and motions of over 1 billion stars in the Milky Way. It's currently keeping JWST company at Lagrange Point 2 as well. Now, they spotted a star in the constellation of Ophiuchus 1,500 light years away that was wobbling on the sky. And that suggests that something is orbiting it if its position is wobbling around. This is actually another way that we can find exoplanets, so planets orbiting around other stars in the Milky Way as well. Planets also cause stars to wobble. But in this case, this sun-like star's motion was a lot bigger than what you'd expect to find for a planet. And so instead, they worked out that the object that was orbiting it must have been between 5 to 10 times heavier than the sun. So heavier than this sun-like star that it was orbiting around. And yet there was no other visible object around it. I mean, if it was actually a star that was 5 to 10 times the mass of the sun, it would be 500 times brighter than the sun-like star that we could actually see. So there's no way that we could have missed it. This suggests that it is a dark object like a neutron star or a black hole. But with the minimum mass around about 5 times the mass of the sun, that's above the maximum mass limit for a neutron star, at which point, you know, neutrons that neutron stars are made of, arranged, you know, as tightly packed as they can go, can't resist the force of gravity crushing them down anymore, and they collapse into a black hole. That limit is around about 3-ish times the mass of the sun. And so this thing, really the only thing it can be, is a black hole. Now this raises all sorts of questions about how this sun-like star orbited by a black hole at this distance could actually have formed and come to be. But it also gives us this new candidate for the closest black hole to Earth. Now, the previous record holder that's actually confirmed as a black hole from X-ray detections is V616 Monocerotis, which was discovered in 1986 at 3,000 light years away, you know, over double the distance of this claim. There's also a candidate black hole known as V Puppis orbiting a binary system of 2 stars at 1,000 light years away, discovered in 2008. But this still is only a candidate black hole. It's not been confirmed by the detection of X-ray light coming from the gas that's spiraling around the black hole that's been accelerated to huge speeds and therefore starts to glow because of the black hole's gravity. In V616 Monocerotis' case, we have detected X-rays and the motion of the other star that it's orbiting around, so we've confirmed that it's definitely a black hole. But in V Puppis' case, and in this new discovery's case, we haven't done that yet. So we can't be certain that it definitely is a black hole. We only infer that they're black holes. Either way, this new discovery is, you know, bringing black holes ever closer to our sort of galactic backyard of the Milky Way, which, remember, is nothing to worry about because black holes aren't endless hoovers. This sun-like star orbiting around this possible black hole is absolutely fine. It's having no matter dragged off it right now. So here on Earth, even if there is a black hole 1,000 or 1,500 light years away, we are going to be absolutely fine. Alright, that's it for night sky news for this month. As always, if you snap any pictures of the night sky, especially of fireball meteors blazing across it, send them my way over on social media because I would always love to see them. My social media will be a little bit quieter over the next few weeks as I am taking a very well-earned break, and that means there'll also be no video from me next week either. So until I see you all next, happy stargazing. Before we get to the bloopers, a huge thank you to Mel Science for sponsoring this video. Mel Science is a subscription box service that provides monthly physics and chemistry experiments for kids. Now, I get asked a lot by parents who want to know the best way to nurture their kids' love of science, especially when they're really bright. And I think Mel Science's experiments are a great way to do just that. Because they help nurture that natural interest in science by giving them fun experiments they can do at home with detailed explanations to dive even deeper. Now, I don't have any kids, but I'm a big kid myself, so I've been sent 2 of the Mel chemistry experiment boxes to play with, and they are seriously fantastic. This one is all about testing the acidity of different liquids with pH indicators. The colours are just all part of the fun here. Then this box was all about how different materials burn. Now, I was a pyromaniac as a kid, so I would have absolutely loved this. I promise you though, the experiments are completely safe. They've been thoroughly tested and comply with both US and EU safety regulations. Plus, you also get virtual reality content on top of the physical experiment in the Mel VR app to take your kids' learning to a whole new level of understanding. You can even ditch the written instructions and get a real scientist to guide your kid through the experiment with interactive instructions. And don't worry, each box contains all the materials and reagents you'll need for that experiment. So if you've got a kid in your life that you know would absolutely love a Mel Science experiment box, check them out at melscience.com, or you can click on the link in the video description down below, and then you can use promo code DrBecky50 to get 50% off your first subscription. That offer code is valid for 1 month. So thank you so much to Mel Science for sponsoring this video. And now, roll those bloopers. So without any further ado, let's kick things off and start by looking up. That was the first take! Yes! 4 years of doing night sky news, 48 episodes later, and I finally nailed it on the first take. This is NASA's mission. Didn't Dennis the Menace have a dog called Nasha? NASA. Every time I say NASA now, that's what I'm going to think. Those observations are planned for later this year in December 2022 with JWST's near-specs detector. Near-specs? Specs on. The telescope's just gonna put its specs on. So in each of these images, that little white star symbol marks the position of the star, HIP 65426. Say the hip, ha, hip, hip, and the hip, rockin' and don't stop rockin' in the hip, 65426. Bring on the boogie to planet B. Oh, my brain.